So welcome students. Let us look at this question. Find the principal and general solutions to these four equations. First equation is tan x is equal to root 3, secant x is equal to 2, cot x is equal to minus root 3, cosecant x is equal to minus 2. So we have already seen how to do these questions. Let us apply this process. So the first equation is tan x is equal to root 3. This is a very basic trigonometric equation. So if you have equation of this form, tan x is equal to some number, the first thing that you need to do is choose an angle, choose a very basic angle whose tan is equal to root 3. So the quadrant diagram for tan is plus, minus, minus, plus. So if you have tan x as a positive number, you always get some angle corresponding to this number in the first quadrant, right? So root 3 corresponds to 60 degrees. So root 3 can be written as tan of 60 degrees. So tan x is equal to tan 60. So now that we have remembered the basic answers to these type of equations, you don't need to derive them again. So x is equal to, so obviously if this is a position which satisfies tan x is equal to root 3, correspondingly this allied position also satisfies this tan x is equal to root 3. So how do you express all the solutions? The general solution is given by x is equal to n pi plus alpha. So tan x is equal to tan alpha implies x is equal to n pi plus alpha is pi by 3 in radians. So x is equal to n pi plus pi by 3 is the answer to this first question. Right? So next, you're also asked to find the principal solutions. Principal solutions are those solutions which lie in the first rotation. So the principal solutions are nothing but a set containing the first principal solution is pi by 3, which is 60 degrees, and the second principal solution is pi plus pi by 3, that is 4 pi by 3. So these two are the principal solutions of this equation, and this is the general solution where n belongs to integers. So now let us go to the next question. Secant x is equal to 2. So let's try to draw the quadrant diagram for this. The quadrant diagram looks like this. So secant is positive in the first and fourth quadrants, negative here and here. So secant x is equal to 2. You'll get some angle in the first quadrant such that secant x is equal to 2. So we know that secant x is equal to 2 implies cos x is half. Again, you have 60 degrees. So the basic angle is again 60 degrees, which is pi by 3. That means secant x is equal to 2, and 2 can be written as secant of pi by 3. So now these are the form secant x is equal to secant alpha. So what is the general solution? X is equal to, correspond to cos and secant, it is 2n pi plus or minus alpha. Alpha is pi by 3. So you have this position as well as this position as the required positions, right? So now x is equal to n pi plus pi by 3 is the general solution where n belongs to integers. Now, what is the principal solution? So principal solution is nothing but, so the solution in the first rotation. So you have pi by 3, that's one principal solution. And the next principal solution, you should not write it as minus pi by 3 because minus pi by 3 is a negative angle. That cannot come. So you have to go like this. So this is the required answer. So what I do is 2 pi minus pi by 3. So this is pi by 3. So this angle is 2 pi minus pi by 3. So that is 300 degrees, right? Pi by 3 is 60. 360 minus 60 is 300 degrees. So 300 degrees is 5 pi by 3. So these two are the principal solutions to this equation. This is the general solution. Now let us go for the third. Cot x is equal to minus root 3. Cot x is equal to minus root 3. So what is the quadrant diagram for cot x? Plus, minus, plus, minus. Now cot x is given as minus root 3, a negative number. So what is the basic angle? I won't find any angle in the first quadrant because in the first quadrant cot is positive. So corresponding to minus root 3, you need to go to second and third quadrant, second and fourth quadrants. Either this or this, anything is okay. So what I do is, so I'll go to the fourth quadrant. So corresponding to which angle cot is equal to minus root 3. Again, root 3 corresponds to 30 degrees for cot. Cot 30 is plus root 3. So minus root 3 comes in the allied position for 30 degrees. So you have minus 30 degrees. This is the position where cot will be equal to minus root 3. So I can write it as cot of minus pi by 6. So cot x is equal to minus root 3, and minus root 3 can be written as cot of minus pi by 6. So now once you have cot x is equal to cot alpha, so x is equal to n pi plus alpha plus minus pi by 6. That is equal to n pi minus pi by 6. So this will be the general solution for this. So you might be wondering, can I take, instead of minus pi by 6, can I take 5 pi by 6? Yes, you can take plus 5 pi by 6 also. In that case, the solution will be n pi plus 5 pi by 6. So both are right. Okay. And what is the general solution? Sorry, what is the principal solution? Principal solution is nothing but the first 5 pi by 6. So the first solution is 5 pi by 6. The second solution is 2 pi minus pi by 6. That is 330 degrees. It is 11 pi by 6. So these are the principal solutions. This is the general solution. So now let us go for our fourth question. So fourth question is cosecant x is equal to minus 2. Right? So the quadrant diagram for cosecant looks like plus, plus, minus, minus. So cosecant is minus, so I'll get some angle in the fourth quadrant. So cosecant x is equal to minus 2 implies sine is minus 1 by 2. So 1 by 2 corresponds to 30 degrees. So minus 1 by 2 should correspond to minus 30 degrees, minus pi by 6. So minus 2 can be written as cosecant of minus pi by 6. So cosecant x is equal to cosecant minus pi by 6. So x is equal to n pi plus minus 1 whole power n times minus pi by 6. So this will be the general solution to this equation, cosecant x is equal to minus 2. So you can take a minus common, so you can write it as minus 1 whole power n plus 1 also. And what is the principal solution? So you have one solution here and another solution here, allied positions. So one solution is pi plus pi by 6, 2 pi minus pi by 6. So those are the principal solutions. Pi plus pi by 6, 180 plus 30 degrees, 210 degrees. So the principal solutions are 210 degrees or 7 pi by 6 and 330 degrees, 11 pi by 6. So these are the principal solutions, this is the general solution. So this is how you analyze questions of type 1 if numbers are given. So next, let us look at a slight variation from the previous questions. So the equation given is sine 2x is equal to half. So how do we solve this? So this can also be solved by converting this into a standard type of equation. So sine 2x is equal to half can be written as sine of pi by 6, right? Sine 2x is equal to sine pi by 6. Now we have to consider 2x as an entity. 2x as an entity, sine of something is equal to sine of something. So this implies from the formula, this something has to be equal to n pi plus minus 1 whole power n times pi by 6. We write the general solution. So the general solution for 2x is n pi plus minus 1 whole power n into pi by 6. So this implies the general solution for x is equal to n pi by 2 plus minus 1 whole power n times pi by 12. So this is the general solution for this equation. So what you need to do if you have something instead of x, so you have to take that as something and write the general solution first and then get the correct solution for x. Now, how many principal solutions does this equation have? So we have seen till now that sin x is equal to something will have two solutions usually in one rotation. So if you have 2x in the place of x, the number of solutions in one rotation increases. Let us see how it is happening. So now x is equal to, so if you want the principal solutions, I want the solutions from 0 to 2 pi. So if you put n is equal to 0, if you put n is equal to 0, minus 1 whole power 0 is 1 times pi by 2, you have pi by 12, which is in between 0 and 360 degrees. Next, if you put n is equal to 1, you have 1 times pi by 2 plus minus 1 whole power 1 is minus 1. So pi by 2 minus pi by 12. Pi by 2 minus pi by 12 is 6 pi by 12 minus pi by 12 is 5 pi by 12. This is the next solution. If you put n is equal to 2, so you have 2 into pi by 2, pi plus minus 1 whole square is plus 1. So you have pi plus pi by 12. So you have pi plus pi by 12, that is 13 pi by 12 is the next solution. Next, if you put n is equal to 3, 3 pi by 2 plus minus 1 whole cube is minus 1. 3 pi by 2 minus pi by 12. 3 pi by 2 minus pi by 12. So if you multiply this with 6, 18 pi by 12 minus pi by 12 is 17 times pi by 12. Now if you put n is equal to 4, you have 2 pi plus something. You are going beyond 2 pi. So these are the 4 principal solutions. So instead of x, if you have 2x, the 2 principal solutions are now becoming 4 principal solutions. So these are the principal solutions to this question. So next, the question given is tan 3x minus pi by 4 is equal to 1. So inside tan, instead of x, you have 3x minus pi by 4, that's an entity. So how do we solve this? So tan of 3x minus pi by 4 is equal to 1 can be written as tan pi by 4, right? So now tan of something is equal to tan of something. So this implies this something, which is 3x minus pi by 4, has to be equal to, so with respect to tan, the solution is n pi plus alpha, right? N pi plus pi by 4. So 3x minus pi by 4 is equal to n pi plus pi by 4. This implies 3x is equal to n pi, it's minus pi by 4, if it goes on to that side, you get pi by 4 plus pi by 4 is pi by 2. And this implies x is equal to n pi by 3 plus pi by 6. N pi by 3 plus pi by 6. This implies, so this is the general solution. If I want the principal solutions, I just need to search for solutions in the first rotation. So if you put n is equal to 0, you're getting pi by 6. So if you're putting n is equal to 1, pi by 3 plus pi by 6 is pi by 2. If you put n is equal to 3, pi plus pi by 6. If you put n is equal to, 2, n is equal to 1. So this corresponds to n is equal to 0, this corresponds to n is equal to 1. So correspond to n is equal to 2, you have 2 pi by 3 plus pi by 6. 2 pi by 3 is plus pi by 6. So 4 pi by 6 plus pi by 6 is 5 pi by 6. It is also in the first rotation. Now if you put n is equal to 3, you have pi plus pi by 6. That is 7 pi by 6. This is also okay. If you put n is equal to 4, 4 pi by 3 plus pi by 6. 4 pi by 3 plus pi by 6. That is 9 pi by 6 is 3 pi by 2. So correspond to n is equal to 5. You have 5 pi by 3 plus pi by 6. 5 pi by 3 plus pi by 6. This is 11 pi by 6. So this is also okay. You're going to 330 degrees. You have come very close to 360 degrees. Now if you put n is equal to 6, you have 2 pi plus pi by 6. It's 360 plus some angle. You're going beyond 360 degrees. So that cannot be considered in the principal solution. So you have 1, 2, 3, 4, 5, 6. 6 principal solutions. So as you can see here, you can see a pattern of increase in the number of principal solutions. For sin x is equal to half, if you have order of x, you have two principal solutions in one rotation. So if the order is of 2x, the number of principal solutions is becoming 4. If the order is of 3x, the number of principal solutions is going to 6. So usually the number of principal solutions will be equal to 2 times whatever is the multiple here. Whatever is the multiple here. So whenever you multiply x with some number, it increases the number of principal solutions those many times.